right, this first part is on identifying where a graph increases, decreases, and is constant. So the first one is increasing. So notice this graph is going up like this. So what I tell my students to do is look and see where you have a positive slope. The next one is decreasing, kind of going down like this. Those slopes would all be negative. It's decreasing. And then constant. Straight across, horizontal line. The slope is 0. It's horizontal. Okay, so example. Identify the intervals for which the function is increasing, decreasing, and constant. And they want this in interval notation. Remember, intervals are your brackets and your parentheses. So let's start with increasing. So we want to find out, where do we see that graph having a positive slope? So this is your increasing part. So when we do intervals, we go on the x-axis. X-axis only. So we start at 0 and then we stop at 2. So intervals are on the x-axis only. So it increases from 0 to 2. All right, the next one is, where is it decreasing? So where do we see that decrease? There's a negative slope there and a negative slope there. So I'm going to put little arrows in those blue pieces. So let's talk about this piece first. It's decreasing from negative infinity to 0. Now, this piece here is decreasing. On the x-axis is 2 to positive infinity. Now, the last part, the constant, horizontal line, there isn't a constant. Next example. Increasing starts here and increases to infinity. So on the x-axis, here's 0, but there's an open circle, so it does not include 0. So we're going to do a parentheses, comma, and where does it stop at? Positive infinity. The next part, decreasing, there isn't any. And now our constant. Here's our constant. So where does it start on the x-axis? On the left at negative infinity. And then where does it stop at? It stops at 0. It includes 0. The next topic is relative maximum minimum. So you can go ahead and pause the video if you'd like. So the relative maximum in this example is right up here. And then the relative minimum is down below. So let's go ahead and do this example. So here is our relative maximum at the order pair over 0 up to. And then our relative min, there's two of them, at over 3, down 1, and left 3, down 1. Now, just notice that this graph does go back up and does go back up. So really, these are your maximums, but you can't find out where does it really stop because it goes on forever. All right, even and odd functions. How you test if you have an even function is you're going to evaluate the function for negative x, and if you get your original function back, it's considered even. If you have odd function, you evaluate the function and you get a negative x. So what I've highlighted here is in the yellow. And what it does, it helps us to identify symmetry in our graph. So here's an example of an even function. We have this parabola, and we have this line of symmetry along the y-axis. And imagine if we fold along that y-axis, we would have y-axis symmetry. So notice this order pair -3, 5, and that order pair 3, 5 would match up. Same thing with -2, 0, and 2, 0, -1, -3, over 1, -3. Odd symmetry is when you evaluate the function, you get a negative x, and it's about the origin. So this is your origin, 0, 0. What happens is your x and your y order pairs negate. So if we look at this order pair, -2, -8, symmetry about the origin, the signs both will change to +2 and +8 when you have symmetry about the origin, and when you evaluate the function, you get a negative x. So we're going to go ahead and do this example. It says even or odd functions and recognize their symmetry. So we're going to evaluate the function for negative x. And then simplify it. Negative x times negative x times negative x is negative x cubed. -6 times +x is +6x. We did not get our original function back, but now let's go ahead and take out a negative. So here's our original function right there. And then what's out in front is a negative. So f of negative x equals your original function with a negative out in front. So what does that mean for our symmetry? Look at this example above. If you evaluate the function for negative x and you get original function back, you have an odd function, which tells us you have origin symmetry. Here's another example. G of x, evaluate the original function for negative x. negative x times negative x times negative x times negative x is positive x to the fourth. Go to the next term, negative x times negative x is positive x squared. And we have a negative 2, so it's negative 2x squared. So we look at the original function first, and what we got is the original function back. So what does that tell us? G of negative x equals the original function. So, looking back up here, if you evaluate the original function for negative x, and you get the original back, you have even symmetry, or even function, and y-axis symmetry. All right, our last one, evaluate this for negative x. So h of negative x negative x times negative x is positive x squared. 2 times negative x, negative 2x, and then plus 1. So, look at the original function. Did we get the original function back? No. So now what we do is we take out a negative. We're going to change all of those signs. Did we get the original function back with a negative out in front? No. So we don't have h of negative x equaling h of x, and we don't have negative x equaling the original function with a negative out in front. So we do not have an even function or an odd function. There is no symmetry about the origin or y.